Estimating the sum of a series. Suppose we have been able to use the integral test to show that a series, the sum from a sub n, is convergent, and we now want to find an approximation to the sum s of the series. Of course, any partial sum s sub n is an approximation to s because the limit as n approaches infinity of s sub n equals s. But how good is such an approximation? To find out, we need to estimate the size of the remainder. Big R sub n equals s minus s sub n equals a sub n plus 1 plus a sub n plus 2 plus a sub n plus 3, and so forth. The remainder big R sub n is the error made when s sub n, the sum of the first n terms, is used as an approximation to the total sum. You see the graph y equals f of x, which is figure 3. We use the restarting the sentence. The remainder r is the error made when s sub n, the sum of the first n terms, is used as an approximation to the total sum. We use the same notation and ideas as in the integral test, assuming that f is decreasing on open bracket n to infinity close. So comparing the areas of the rectangles with the area under y equals f of x for x greater than n in figure 3, we see that big R sub n equals a sub n plus 1 plus a sub n plus 2 plus ellipsis is less than or equal to the integral from n to infinity of f of x dx. Similarly, we see from figure 4 that big R sub n equals a sub n plus 1 plus a sub n plus 2 plus ellipsis is greater than or equal to the integral from n plus 1 to infinity of f of x dx. So we have proved the following error estimate. See figure 4, where y equals f of x, and I guess you're starting at n plus 1 instead of n compared to figure 3. Back to the text. Number 2, I guess the theorem number 2, or remainder estimate for the integral test. Suppose f of x equals a sub k, where f is a continuous positive decreasing function for x greater than or equal to n, and the sum from a sub n is convergent if big R sub n equals s minus s sub n, then the integral from n plus 1 to infinity of f of x dx is less than or equal to big R sub n, but big R sub n is less than or equal to the integral from n to infinity of f of x dx.